It's going now, and what I'm going to do here is share my screen, and let's see what's here. Do I have... Here we go. There we go. Do you guys see that? Do you see the solution there or no? Is it coming through? It is? Okay, cool. Okay, so let's just go through some of these exercises. If you don't mind, I'll read number 20-1, and then if I'll explain these as we go, and rather than have you guys read them or whatever, I'll just try to explain them as we go because this goes pretty quick. So following is a list of various costs for automobile parts. With respect to the production and the sale of these parts, classify either as variable, fixed, or mixed costs. So variable, of course, changes. Fixed, it stays constant. The mixed, what that means is, for instance, like your photocopier lease. The photocopier lease is $1,000 a month. If you don't even turn the thing on, it's $1,000 a month. The moment you start making photocopies, it's $1,000 a month plus 0.001, so just less than a penny per copy. So that's a mix. So it's fixed for the first 1,000, and then it starts to go up after that. So oil in the manufacturing equipment, of course, is variable. Plastic, are you doing 10 units or 20? So it's variable. Property taxes, that number is fixed. It's the same all year. Salaries are always fixed. When you got labor, which is hourly, of course, that's variable. Packaging, kind of like the plastic or the oil, that's variable. The factory cleaning costs, $6,000 a month, fixed. Metal, just like the packaging, variable. Rent, here's a new one. It's $10,000 per month plus $25 per square foot of storage used. So that, of course, then is mixed. Same with this next one, number 10. It's $3,600 a month plus how many pennies over the $1.2 million threshold. So that's mixed. Straight line depreciation is fixed. Anything that's hourly is variable. Of course, electricity, on or off, variable. Computer chips, depending on how many cars you're producing, variable. And then the pension cost, of course, depends on how many employee hours, variable. Any questions on number 1? Those are pretty straightforward. Number 2, these are all pretty straightforward. There's 2 of them, though, that are tricky. So which graph describes it best? Total direct material costs. Total direct materials costs. So as you produce more, that line will go up because in total, that number will go up. So that's graph 3. Letter B, the electricity, that's $1,000 a month. So this is a mixed question, and that would be best described as graph 4. It starts at a number, and then based on that, it'll go up from there. Straight line, letter C, of course, that's, excuse me, I missed one there. Per unit cost of straight line depreciation. So straight line depreciation, this is one of them that's tricky, letter C. You would say, well, that's, a lot of folks would have picked graph 2, but it's actually graph 1. And let me explain. Straight line depreciation is a fixed cost. Okay, so that line should be flat. However, we're talking about per unit. And that's what I would circle or highlight in your book, because if we produce 10 units, we got to split that straight line depreciation over 10 units. If we produce 10,000 units, then we split it over 10,000 units. So per unit, the more you make, the further down that line will go or curve down. So that's graph 1. Very few, way at the top. And as you produce more, it'll go to the right further down. Salary, letter D, of course. Salary is fixed. graph 2. And then here another one, letter E. This is the other second tricky one. Per unit direct labor cost. Okay, per unit. So if you're paid 20 bucks an hour, you're paid 20 bucks an hour, not talking about overtime, 20 bucks an hour. So in total, it's different because did you work 5 hours or did you work 10 hours? So in total, but the per unit, the $20 number, that stays the same. You're going to get paid 20 bucks an hour if you work 5 hours, or if you work 10 hours, or if you work 25 hours. It's still a per unit of 20 bucks an hour. Any questions on number 2? If you move to number 3, it just reads, for a major university, match each of the following table with the activity base. So what they're trying to have you understand is what drives those costs. Okay, so for number 1, financial aid office salaries. Well, that financial aid office is going to probably be driven by how many salaries are we going to need? Letter E, the number of financial aid applications. Doesn't mean that they came, but those are what's going to dictate how many salaries we're going to have to incur just to run them all. Okay, office supplies, you know, I think we're going to go through office supplies depending upon how many students we have on campus. Letter B is probably the best answer there. That one's not as straightforward. Instructor salaries. Okay, so a lot of times folks will say, well, it could be letter B, but what's better yet is letter C, student credit hours, because if you have one student only taking one course, that's only one salary. But if you got one student taking the traditional 5 courses, 15 credits, 15 divided by 3 is 5 credit, 5 classes, that would dictate how many salaries there would have to be. So it's going to be based more on hours. Letter F, or excuse me, number 4, housing personnel. Okay, well, that would be housing, letter F, students living on campus. Number 5, employee wages for maintaining student records. Again, student records means if they're here today or if they were here yesterday, they are a graduate. That would be letter D, enrolled and alumni. Admissions, of course, that would be letter A, the number of enrollment applications. Okay, not too tricky here. Number 4, it says again, identify those cost bases. Number 1, the preparation cost for cleaning oil and gasoline of each car received. Each car received. Well, letter E, number of cars received. Number 2, the salesperson's commission of 5% of the sales price for each car sold. Some would say letter A, number of cars sold, but are we talking they were selling, you know, a Maserati, or are we selling, you know, a Pinto? So it wouldn't be that. It would be based on the number of the dollar amount of cars sold. Letter F. And then number 3, the administrative costs for ordering cars. The administrative costs. And that best answer would be number of cars ordered, letter C. Okay, number 5, it just wants you again to pick variable or fixed, So we can go through those. Packing costs, of course, variable. Sales commissions, variable. Property taxes, we pretty much know is fixed. Shipping, of course, variable. Straight line, fixed. Letter F, salary, fixed. Salaries again, fixed. Salaries again, fixed. Wages, that's hourly, so that's variable. Cost of providing online support, variable. And the user guides, variable. Nothing too difficult there. So before we move on, any questions 1 through 5? All right, good. Number 6. Number 6 is a good one in that it kind of reinforces what we looked at when we did those graphs. okay, when you look at those graphs. So let's just look at here on this solution here. So 40,000 units produced, 80 or 120. So what you can say right away is they gave us that. Total fixed, so that's just like real estate taxes, total is going to be the same no matter how much you produce, the total. But look at here, the fixed cost per unit, right? That is what we were talking about. That fixed cost now gets split over more units. Therefore, the fixed cost per unit is going to go down. Make sense? Likewise here, variable cost per unit. Variable cost per unit. Well, that's they gave us the 720. So 720 divided by 40,000 is 18 bucks. Okay. Well, that's like the hourly wage. They're going to be paid 18 bucks an hour no matter what the volume is, but in total that will change. Okay. And then these F and I, C, I, and O, those are just the totals. So really what I really want you to catch in this problem, if you will, is right here, the fixed cost in total stays the same all the way across. In total, the variable cost, of course, will increase. Again, we're talking total. But when we look at variable cost per unit, think about hourly wages, that stays the same. And that's not what our mind wants us to think, but that stays the same. But the fixed cost per unit, which we would want that to stay or look to be the same, that hey, are you still there? I just checked to see what happened, and I just got a note from IT that Nathan disconnected me from the internet. So I don't know what he did, how he did that. I don't know what happened. I don't know what happened there, but I'm back. So do you just see my face, or do you see the solution? Okay. Let me see if I can fix that. Is it back now? All right, cool. So really what we want to just make sure that we note here is these two lines here are significant, and these two lines are significant. Number 6 is a really good question that we don't want to forget. Any other questions then on number 6? Okay. Well then, let's move to number 7. Number 7 is kind of an interesting problem. It's called the high-low method, and essentially what we're doing is we're trying to back into fixed costs. And you'd have to look in the text to see how this works, but we're trying to calculate variable cost per unit, okay? And that's what we'll calculate, and therefore we can back into fixed costs. And how it works is you look at the information you have and you take the high and the low of total costs and the high and the low of the units produced. Okay, so the high of the units of the total costs is, you look in the total cost column, the highest is 32,120, the lowest is 25.1. As far as units produced, the highest is 120,000 and the lowest is 80. So the difference then on the numerator is 7 million and the denominator is 40,000. And by calculating that, that gives us the variable cost per unit. Well, What's the total cost? The total cost per unit is variable costs plus fixed costs. And how it works is fixed costs, it doesn't have any matter to how many were produced, but the variable cost per unit does matter because we want to know how many units we produce. Because like Little Caesars, if there is no pizzas sold, then we will not have the cost to put into that pizza that we did not sell. So then our only cost then is fixed costs. But when we start selling pizzas, it will be the per cost unit times the number of pizzas that we intend to sell. The sum of that plus the fixed cost is our total cost. So in this case, just to make sure that we have it right and that this is correct, we can say for the total cost is, let's just pick the highest one again, 32.12 million. That should equal the variable cost per unit times the units produced, and the 32 level is 120,000 units plus fixed costs. We don't know that number yet. So 32 equals 21 plus the fixed costs. We solve for fixed costs, it comes to 11,060,000. Well, let's keep going and see if it works for the lowest level. Lowest level, again, it was 25.1 million. Same unit cost. At this level, it was 80,000 units plus fixed costs. Again, dropping here, our same fixed costs. So now we know the variable cost per unit, we know the total fixed costs, and we can always calculate then the total. So in letter B, it just says, based on part A, estimate the total cost here of 115,000 units. Well, 115,000 units times the variable cost per unit is 20,182,000. We still add the same fixed costs because it doesn't matter what the volume is. Our total cost here then is 31.2425. That's how the high-low method works. Moving on to number 9, and where this is all getting to is right here. We're going to try to figure out what is our contribution margin. So number 9, it says, Young company budgets sales of 112.9 million, fixed costs of 25 million, and variable costs of 66.6 million. What is the contribution margin ratio? And this is something we'll have to know. How do you get to contribution margin? Sales minus variable costs is a contribution margin. This number here is what has to pay for or cover all of our fixed costs. So the ratio is no big deal. It's 46,289,000 divided by 112.9 million, and that tells us our ratio, our contribution margin ratio, is 41%. Another way to say it is for every dollar we sell, we make 41 cents, and that 41 cents is what has to cover all of our other fixed costs. Okay. So again, going back to Little Caesars, let's say they sell the pizza for $5. The pizza has a cost of 50 cents. So for every pizza we sell, we're making $4.50. How many $4.50 earnings do we need to make in order to cover all of those fixed costs? And certainly these retail stores know exactly how much do they have to have in sales every day to break even. And this is probably the best time, honestly, with this whole Corona thing going on, why you see these restaurants now, really pushing drive-through or carry out or delivery, because what they're trying to do is everything they can just to cover their fixed costs. And I suspect many are not doing that. Letter B says, based on part A, letter B, if the contribution margin ratio is now 40%, sales are 34.8 and fixed costs are 1.5, what's your operating income? Well, again, we could do sales minus our variable cost as contribution margin. Well, the sales here says 34.8 million. And what we could do is just take it straight times the 40% to get to contribution margin. Or you would take 34.8 times 60%, and that goes right here. And then we take the difference, and that's your contribution margin. Or, since we know this ratio, we could take sales times that ratio. Our contribution margin is 13.9. Our contribution margin far exceeds our fixed costs, and therefore we've got nice operating income. Questions on number 9. Number 9 literally leads us into number 11, and this is what we're trying to get to is, so how many pizzas does Little Caesars have to sell to break even? Well, this is how we calculate break even, and this is also a form you need to know. Fixed costs, and this problem said fixed costs were $27.6 million. It says they had a variable cost of $805 and a selling price of $1150, and we divide it by the unit contribution margin. So the selling price was $1150, the variable cost was $805. So the difference between that is our contribution margin by unit. In order for us to break even, the difference between these two times 80,000 units will cover that cost. So just like Little Caesars, $5 sales price, 50 cents variable cost, that's a $4.50 unit contribution margin. $4.50 times 10,000 pizzas will cover our fixed costs, whether that's per the day or per the week or however. But we don't want to just break even. We want to know how many pizzas do we got to sell to break even and make X amount of dollars. Well, that's part B. They want to make 5.175 million. So then what you're doing is this fixed cost is a hurdle. We got to get over that in order to break even. Well, now what we're going to do is just going to make that hurdle even higher. So it's fixed cost plus that number. Well, of course, if we're going to increase this numerator, you would expect this to be higher than when there is no profit, because this is just breaking even. So now if we sell 95,000 units, we will make 5,175,000. This is not a trick question, but somebody tell me, if we sell 80,001 unit, 80,001 unit, can anybody tell me how much money do we make? Anybody want to guess? We sell one more unit than what it takes to break even. How much money are we going to make? Nathan? Or Jackson? Either of you two? You bet. So the answer would be, I think it's $345. I don't know if anybody else had that. And how did I get that? That's the difference between these two right here. Selling price minus the variable cost is our contribution margin per unit. So if we sold 80,000 units, that just covers this. But if we sold 80,001, we would have that covered plus the net, another $345. Everybody understand that? Okay. Holler if you got questions. Let's look at number 13. It's really kind of the same thing. Now it's asking for us to calculate break even in sales again, or units. Currently, the unit selling price is $75.20. The unit variable cost is $4,400, and the total fixed cost is $23.4 million. Okay, well, here we go. 23.4 million is the fixed. Here is our sales price. Here is our variable cost. That difference divided by, or 23.4 million divided by this difference, that is 7,500 units, and it breaks even. Well, in part B, it says, compute the anticipated, assuming that the unit selling price stays the same. Well, it says here above, a proposal is being evaluated to increase the unit selling price. Well, it doesn't take a rocket science to figure out if you're increasing your selling price and everything else stays the same, the variable cost and the fixed cost, we will not need to produce or sell 7,500 units. We will sell 1,000 units less because of this number right here going up, 8,000, right? So, yeah, you can quickly figure out how many, these variables can change. So if your fixed costs go up, you got to sell more in order to break even, correct? Or if your selling price goes up and everything else stays the same, you will sell more. You will sell fewer units to remain the same. Or if your variable costs go up, you will have to sell more units to break even. Okay, questions on number 13? And then number 19, if you just look in your textbook and what's going on there in number 19, you see that graph. Well, letter A, that's the break-even point. That orange shaded area, letter B, that's the point where from the break-even going down, that's loss area, versus going to the other direction in the green, that's profit, right? Letter C, that's the total cost line. And I would tell you with letter C, I would say that's a mixed cost, right? That's a mixed cost type of scenario because it doesn't start at zero. It starts at 50,000 and goes up. So letter C is the actual total fixed costs, fixed. And then going up, that's letter D, that's the total cost line. So it's going up, the variable part, if you will, the mixed part. F, after you break even, that's the sales line continuing up, going up. That's the sales line. I think we've identified all the letters then in number 19. So we'll stop there for today. It's not a terribly long day. What we'll do on Tuesday, all I ask is if you could look at problems 1A and 2A. And seriously, problem 1A should take you about 5 minutes. It's just identifying variable, fixed, or mixed. It's really quick. And problem 2A is, again, just looking at all these costs and identifying them as variable or fixed. Variable or fixed. And it's in a little bit more of a different format. It's in that operating income type of format. So look at that. Let me stop sharing my screen here a minute. And I don't know if I came back or not. There, all right. So let me just give you again. So Tuesday we'll just finish those two problems. So that's all you got. Then after that, our first exam, since this whole online environment takes place, will be on the April 9th. So it's a week from today. Okay, a week from today. And there's really only 3 chapters. 15, 16, and 20. Remember, we only covered like 3 or 4 exercises out of 17. I didn't want you to read it, but just those 3 or 4 exercises. So 15, 16, 17, and 20, but it's really just 15, 16, and 20. Okay? That's a week from today. I'll send out a review sheet. The take-home exams, I believe, are out there already and open. Let me hold on here a minute. I think I'm gonna. I misspoke. So I think I have it set, and I'll double check this. But I think the take-home exams are not due till the 9th of April. The 9th of April. If you look, is that right, Jackson? If you see that on the on Cengage. So we won't take our exam, if you will, that in-class one that we would typically call that, not till the 12th. So you got some time there yet. So, and that will be online, of course. That one I think will be administered through the LMS. So you'll see it there when it's time to open. The same take-home exam, just like you're used to. You got plenty of time to get that done between now and the 9th. That's 7 days from now. Yes, Nathan. I think so. I'm not going to make it so tight that it has to be done between 11 and 12:15, but maybe that day, just sometime that day. A good question. I'm glad you asked that. So those, I think that's really what I needed to tell you about the take-home exams, online exam. That'll go through the LMS. Do you guys have questions for me? Nathan, you're making me hungry. What are you eating? Oh my gosh. Okay, so here's something that you guys, this is some extra credit for you. This is the simplest, this is the easiest extra credit you're going to get in your academic career. If it's harder than that, if it's easier than this, then I don't want to know. On Tuesday, we'll get, of course, to get back together for problems 1A and 2A. All you need to do is wear your favorite USF attire, whether that's a sweatshirt, a t-shirt, a USF hat. You guys will get extra credit for just wearing USF purple, something purple. Just wear something from USF and you'll get extra credit. Probably even enough so that you don't even have to take the test. We'll say you take the test or wear, probably not quite that good. All right. So you guys have any questions for me? Alexis, I don't see you out there anymore. Okay. Any questions? All right. Hey, you guys have a good day. Have a good weekend. And if you need anything ever, just shoot me an email or give me a call. My office number brings it straight to my cell phone, and we'll go from there. Have a good day, guys. See you later.